Hello students, welcome to groundwater and hydraulics subject. We have started with module 4, that is geophysical exploration. What are the different methods for exploration of groundwater? So in previous class we had discussed how the seismic method is performed and how the results are obtained. In today's class we will discuss the electrical resistivity method. So what is mean by electrical resistivity method? So all geological formations, they have a property called electrical resistivity, and this resistivity is expressed in terms of ohm meters. So the unit of resistivity is ohm meter. So when we pass the current into the ground, right, the different material, they behave differently, right? It depends upon their properties. So this method makes use of that fact that the water increases the conductivity of the rock and thereby decreases their resistivity. So here this is a geophysical method wherein we apply physics. Okay, so here we pass the current into the ground, and when the current passes, okay, if there are water bodies, what happens? The water increases the conductivity of the rock. So the conductivity will be increased and you will get the resistance which is recorded, it will be less. So if you get the result as less resistivity, then there will be a presence of water. So this is the principle behind the electrical resistivity method. So the various geological factors which influence the electrical resistivity of the subsurface formation. So this is performed below the surface because we are passing the current below the ground. Okay, so what are the factors which affect the electric resistivity method is, first one, the mineral content, because we know what is a rock. Rock is an aggregate of minerals. So most of the rock forming minerals, they have the high resistivity except sulfide minerals. So the mineral content which is present in the rock, that plays an important role here. Then compactness, whether it is hardly compacted or poorly compacted. Okay, so whether it is loose or compact, that also affects the electrical resistivity. Then next is moisture. So as I told you, moisture, if there is more moisture, more water, the conductivity increases but the resistivity decreases. So moisture may occur in the rock also, so that also affects the resistivity. Then the salinity of the moisture, okay, whether it contains some dissolved salts, that also affects the resistivity. Then the last one is texture of the rock, whether it is fine grained rock. If it is fine grained, it shows a higher resistivity compared to the coarser grained. So the grain size or the texture of the rock, that also affects the electrical resistivity of the formations. Then, so these are all the factors which influence the electrical resistivity of the formations which are there below the surface. Next, the resistivity means what? Resistivity, or it is the inverse of electrical conductivity. So what is that resistivity? It is a measure of the capacity of a rock to allow an electric current to pass through it. So that is called as the resistivity. What is resistivity is? It is the inverse of electrical conductivity. That is, it is a measure of capacity of a rock to allow an electric current through it. So whether the rock is allowing the current to pass through it or not, that is decided by the resistivity. Suppose if the rock is dry, okay, dry rocks and sediments, then dense, compact and non-porous rock, these rocks will offer a great resistance to the electric current compared to the loose, porous, wet and saturated material. So if the rock is loose, porous, if it is wet, if it contains water, then it will offer a greater resistance to the this will offer a less resistance compared to the hard and dry rock. Okay, so then there are two variations of resistivity method. So there are two variations. One is profiling method and other one is sounding method. So there are two methods. What is mean by electric profiling and electric sounding? So these are the two methods or the two variations in the resistivity method. So profiling method is lateral exploration. We find or we search for the water laterally, so it covers a greater distance. Okay, whereas sounding method, that is vertical electrical sounding, it is also called as VES. This is penetrating deeper and deeper into the ground, whereas profiling method will be lateral. So these are the two variations in the electric resistivity method. So what is that profiling and sounding? We'll see. Profiling, or it is also called as traversing. So this is done to detect the lateral changes in the resistivity, which reflects the subsurface lithology in a large area up to the same depth. Okay, so what is mean by profiling? Suppose this is the ground level, okay, and you are sending current into the ground. Okay, then profiling, in profiling what happens, it will detect the lateral changes in the resistivity, which reflects what is there in the subsurface lithology. Lithology is information about the rocks. Okay, so what type of rocks are present below the ground, that information will be given, and it covers a large area. The area coverage is large and the depth remains the same. That is called as profiling. So here depth remains the same, but it is lateral extent. Okay, then what is mean by sounding? That is vertical electrical sounding, VES. So this is done to determine again the changes, the vertical changes in the resistivity, which reveals the changes in the lithology at a particular place with a increasing depth. Suppose this is the ground level. Okay, and if you perform the sounding method at this point, if you are doing the test, then it will go vertically downward and it will cover a limited area. Okay, at this particular depth or this particular area below the ground, what is there, it will give the information. So it is done the sounding is done to determine the vertical changes. Okay, vertical changes in the resistivity, which reveals the change in the lithology, that is the rock characters, at a particular place with increasing depth. So this particular place with increasing depth, it will give the information. Whereas in profiling, it covers laterally. Okay, laterally for a longer distance up to same depth, it will give the information. So that is the difference in electrical profiling and sounding. Next, in profiling, or it may be a sounding, whichever method we are using, there is a scope for electrode arrangements to be made in different ways in the field, as such arrangements are called as electrode configuration. So what is mean by electrode configuration? Because we need to send the current into the ground, we need to place the electrodes on the ground. Okay, and these electrodes, with the help of the current supply, okay, we can pass the current into the ground, okay, and such type of arrangements, okay, what type of arrangements you can made with the help of electrodes, that is called as electrode configuration. So there are two main methods of electrode configurations which are commonly used. One is Wenner configuration and other one is Schlumberger configuration. Wenner and Schlumberger, these are the names who invented those methods, okay. So Wenner and Schlumberger, these are the two electrode configurations or two methods which can be performed to determine the electric resistivity, to perform the electric resistivity method. So now this is how in the field we perform the electric resistivity method. You can see there are 4 electrodes, okay, they are rods, okay, metal rods which we need to insert into the ground, okay. You can see these are inserted into the ground, and with the help of wires, these are the wires, okay. So there will be 2 current electrodes and two potential electrodes. These are the potential electrodes and the outer one are the current electrodes. So we need 4 electrodes to perform this test, okay. So this is the instrument which will give us the result, that is the resistance it will give, okay. So here these are attached with the help of cables to the instrument, okay. We need to supply the current. So this is how the in field with a proper arrangement we have to perform this particular electric resistivity method. So in electrical resistivity method, the electrical resistance which is determined by applying the current, that is I, to the outer electrodes. So these two are the current electrodes. You can call them as C1, C2, okay. These are the current electrodes, or you can call them as AB, which are current electrodes, and the inner electrodes, they are called as potential electrodes. So you can call them as P1, P2 also, or MN, okay. So these are the 4 electrodes. So current electrodes, they are also called as outer electrodes, and potential electrodes, they are also called as the inner electrodes. So the current, okay, current is sent into the ground with the help of current electrodes, and we have to measure the apparent potential difference, that is the V, between the two inner electrodes or potential electrodes which are driven into the ground. Then changing the spacing of the electrodes, okay, changes the depth of penetration of the current. So here in this particular method, what is done in Wenner and Schlumberger, I will tell you. So here first we'll understand general what is done in this test, okay. So there are 2 current electrodes and 2 potential electrodes. So when you send the current into the ground, so the current will move from first current electrode to the second current electrode, that is from A to B, the current is moving. You can see here, right? So here the current is moving from A to B. So as you increase the spacing between them, it will increase into the depth, okay. So for in the figure it is just shown the spacing is constant, but you can change the position of the electrode so that the current will go deeper and deeper. So that is the logic behind the sending current. You can go deeper and deeper as you increase the spacing between the electrodes. So changing the spacing of the electrode, that will change the depth of penetration of the current and the apparent electrical resistivity, that is rho A, that is obtained at a different depth by measuring the resistance, that is R. Okay, by measuring the resistance R we know that is V by I. Okay, R is equal to V by I. So this is later we have to plot a graph, okay, based on using double log or semi log paper you have to use, and you have to plot the values of resistance and depth. So the depth at which the current enters the formation of higher or lower resistivity, that is signaled by change in the resistivity, which is recorded on that instrument which I had shown you, right? In the previous slide you can see this instrument, it records the resistance. Okay, so this is recorded, and as there is a change in the formation, you will see the change in the resistance which is offered by the ground. Okay, so this is recorded at the ground surface, and by proper interpretation of these resistivity data from the field obtained, and you can compare with the standard available results, and with the help of that graph it is possible to identify the water bearing formations, and accordingly the limit you can limit the depth of the well which you are going to drill in that particular area. So this test is usually performed to know the availability of water in a particular area. Next we'll see what is the difference between Wenner and Schlumberger arrangement. So there are two electrode arrangements I told you, right? So Wenner and Schlumberger. So first we'll see how will be the Wenner configuration. So the electrodes are spaced at equal distance, okay, and the apparent resistivity, that is rho A, okay, for a measured resistance, that is R is equal to V by I, okay, that is given by this particular formula. So first what is done in Wenner, I'll tell you. So these are the two electrodes which are potential electrodes, and these are the two current electrodes, C1 C2 and P1 P2. So in the Wenner configuration, the spacing between all the electrodes will remain same. Suppose at this point I want to know what is there below the ground. So what I can do, from this point on either side, suppose it is the spacing, suppose it is 1 meter, okay, then this also remains the same. So 1 meter, 1 meter. So all the four electrodes, they will move simultaneously at each next reading. So suppose I have kept this as 1 meter. Next, for next reading, next resistance meter will be there to record the resistance, okay, which is offered by the current passing into the ground. So when you send the current into the ground, it will move from C1 to C2, and the resistance is measured with the help of resistance meter. Potential electrodes will measure the resistance. Then for this is done, then for the next set of reading, what you will do, you will shift all these four electrodes on either side simultaneously. P1 P2 will move 1 meter ahead, then C1 C2 again move 1 meter ahead. So like that you have to move all the four electrodes simultaneously. This is done in Wenner configuration, and the resistance, that is rho A, is given by this particular formula, that is 2 pi a r, where you can replace r by V by I. Okay, so here what is A is the distance between the electrodes, Okay, suppose you have kept it 1 meter, then you have to write it as 1 meter. If you have kept it at 2 meter, then you have to write it as 2. So A is what? The distance between the electrodes, adjacent electrodes. Then V is the voltage. Okay, voltage difference between the potential electrodes, and I is the current applied. Okay, applied current, that is the I. So we can set how much current we are sending into the ground. So that arrangement will be there. You have to take a battery which is charged and you have to go to the field and perform this particular test. So A is the electrode separation, that is the distance between the electrodes or electrode separation. V is the potential difference, and I is the current sent into the ground. Okay, and rho A is the apparent resistance that will be calculated, and the unit will be ohm meters. So this is done in Wenner configuration. Next is Schlumberger. What is mean by Schlumberger configuration? What is done in this particular test? In Schlumberger, the distance between the two inner potential electrodes, that is P1 and P2, that is the distance, you can call it as B. Okay, the distance between the potential electrode is B. So that is kept constant for a set of readings, and the distance between the current electrodes is varied, that is C1 and C2. Only you have to move the C1 and C2 for a particular set of reading. Then the apparent resistance is measured, that is R is equal to V by I is measured like Wenner. Okay, but here what is done, what is the difference between Wenner and Schlumberger is, in Schlumberger these two electrodes are kept constant for a set of reading, that is suppose these are initially at 1 meter. Okay, so 1 meter is the distance of potential electrode. Then current electrode, the distance suppose it is 2, then 4, then 8, then 10. After 10, okay, these only current electrodes we are moving. Up to 10 we have gone, 10 meter. Then after 10, okay, you have to shift the potential electrodes, that is from 1 meter to 2 meter. Okay, so P1 will be moved, P1 and P2 will be moved to 2 meter for the next set of reading, that is from 12, 14, 18 like that, 16, 18 like that. You can keep a distance of 2 meter and you can measure the resistance, and then you can use this formula to find out the resistance. So you have understood now what is the difference between Wenner and Schlumberger. In Wenner, all the 4 electrodes are moved simultaneously, and in Schlumberger, P1, P2 are kept constant for a set of reading, and only current electrodes are moved, and after a set of reading again the potential electrodes are moved, and again the readings are taken. So here the rho A, okay, that is the resistance, that is calculated by this formula, that is pi L by 2 square, that is the distance between the current electrodes, that is the capital L, okay, minus the small b, that is the distance between the potential electrodes, that is b by 2 into b by 2 square divided by b, that is the distance between the potential electrodes, into R. So this formula is applied when L is greater than B. Then again you can write the same formula as R is replaced by V by I, okay, and when if the L is greater than phi B, then you can directly calculate by this formula, that is rho A is equal to pi L square by 4B into R. So if this formula is used if L is greater than phi, okay. So this is how the electric resistivity method works. So here L is the capital L is what? It is the distance between current electrodes. B is the distance between potential electrodes. V is the potential difference. I is the current sent into the ground, and rho A is the apparent resistance, which is calculated as ohm meter. So when you plot these, okay, when you get these values, okay, you have to plot a graph, okay. So in this method, the 4 types of master curves are interpreted depending on the resistivity variation with the depth. So there are 4 types of curves like A type, Q type, K type and H type. So what is this A type and all these types of curves? So first, these are plotted depth versus the rho A, that is the resistance, okay, depth versus resistivity. So suppose at this particular depth the rho A is this much, then as you increase the depth the resistivity also increases. Then this type of curve is called as high, high and high, because the values are increasing. Here suppose at the lesser depth the resistance is high and the resistance is decreasing with the increasing distance. So this is high, low, low. So this type of curve is called as high, low, low, that is Q type. Then K type curve, how it will be? Initially it will be less, the resistance is less, then it increases and again it decreases with the increasing depth. So that is low, high and low. And one more type of curve is initially the resistance is high, with the increasing depth the resistance decreases and again the resistivity increases as you go deeper. So this is high, low, high. So these are the 4 types of curves which will help us to interpret what is there below the ground, okay. So this electric resistivity method, it works on one principle I told you. What is that? Water increases the conductivity and thereby decreases the resistivity. So if there is a decrease in the resistivity, what it shows? If there is a decrease in the resistivity, this is less. So here there is availability of water up to this depth. Then resistivity is higher and higher. So there will be less availability of water at this particular depth. That is how we have to do the interpretation of these curves. So now here it is high at this point, okay, at this depth resistivity is high, okay, means what? At this depth water is less and as you go deeper and deeper there is a availability of water. Same way here there is a if it is less, okay, decreases the resistivity. So decrease in the resistivity is the indication of water here, and here there is a water at this depth, and at this depth there is less water or there is no water present in it. Same way here there is a water at this depth, and here there is less availability or no availability of water. So this is how this curve will help us to interpret the given results. So these are the 4 types of curves which are obtained when you plot the apparent resistivity versus depth. So this is the electrical resistivity method, which is very important question from exam point of view. So this will tell us the availability of water, the groundwater, and what type of lithology or the rocks are present in a particular depth. That is also given, or we can interpret with the help of this electrical resistivity method. Thank you.